All right, well, let's take a look at these couple warm-up problems and jump in here. Do you guys remember FOIL? So remember, FOIL stands for first, outer, inner, last. And I tried to leave some space above each of these. So 2x times 2x is what? Somebody quick. 4x squared. Outside is how much? Negative 6x. Inside, plus 6x. Last, negative 9. All right, so 4x squared, what happens to our middle terms? They disappear. Okay, so we're left with 4x squared minus 9. All right. Each one of our warm-up problems kind of gives us a different piece to try. Let's look at letter B. You see that 5 out front? We're going to deal with that 5 at the very end. So don't do anything with it right now. Let's just focus on the middle. Okay, just focus on what's in the middle here. Whoops, sorry. Just focus on this right here. What's x plus 2 times x minus 2? Well, let's see. X times x is x squared. Outside is 2x. Inside is negative 2x. Last is negative 4. What happens to the middle two terms? They cancel. That leaves me with 5 times x squared minus 4. Now can I deal with the 5? All right, Paul, distribute that for me, please.
5x squared minus 20.
Okay, so there we go. Okay, you try C very quickly. Shouldn't take you long. Go ahead and do C. X plus 7 times x minus 7. Plus is right. I just want to make sure you're realizing it's a different than what we had before. Do the middle terms cancel on this one? No, they do not. Okay. So, what we have is the first term is called the difference of two squares. The second term is the difference of two squares times a coefficient in front. But the third term, do you recognize that I could have written this like this? I could have started the problem like that, but I didn't. I kind of said, hey, it's the two binomials. And this is called a perfect square trinomial. A perfect square, because we got it by squaring something. Trinomial, if you remember, trinomial is because it's 3 terms. Trouble spelling here. Nomial. Okay. All right. So that's kind of our kickoff as to what we're going to be working with and using today in our factoring. So let's start with the difference of two squares. Do you remember what 2x plus 3 and 2x minus 3 are called to each other? It was a big word. It began with the letter C. It had to do with the word con. This is a long time ago. They were called conjugates. Conjugates. Okay. A conjugate is very simply two binomials that are exactly the same except one's a plus and one's a minus. So at the top there, that 2x plus 3 and the 2x minus 3, those are conjugates. And the beautiful thing about conjugates, Stephen, if you remember, is the middle terms drop out when you multiply them. So here we have a difference of two squares problem, x squared minus 49. And so what you need to realize is, what multiplies to 49 that adds to 0? 7 and negative 7. And so my answer is x plus 7 times x minus 7. And once again, those are called conjugates. These occur when you have something squared minus something else squared. So, yeah, that's the answer. In example 2, do we have something squared? What's being squared? 2x. So we have 2x and 2x. And then 25 is something squared. That's 5 and negative 5. Now, there's no rhyme or reason as to why one is positive and one is negative. It doesn't matter the order you put them in, so long as you put one of each. And once again, let's just say what these are called. What's the big fancy word for these two binomials? Conjugates. All right, let's look over here at example 3. Who feels they can give me the two conjugates? What times itself is 100? So I have 10x and 10x. One's a plus, one's a minus. And 10x plus 1 and 10x minus 1. Thanks to you, Alexis. So these three are examples of the difference of two squares, which is abbreviated as dots, which factors to conjugates. It's going to be the easiest factoring problems that we have. Questions? Is this familiar or is this foggy? Grace?
What is this chapter about?
This chapter is all about quadratics, and the bottom line is a quadratic, which is in this form, ax squared plus bx plus c, has some type of a graph. And the entire chapter is about finding that point, and that point, and the vertex. And so different parts of the chapter are focusing on different pieces. What we're doing right now is we're leading into finding the vertex or finding the x-intercepts. So big picture, it's a quadratic. What is a quadratic? A parabola. And where do they cross the x-axis? And we're leading into, by factoring, finding some of those places. It may not seem so like at the time, but they do all kind of weave together. It's kind of like an orchestra. When the bassoon plays, you're like, I don't really understand why he's playing those notes until you get the big picture of the orchestra all together. So, all right. Well, let's look down here at some factoring involving things we've done so far. I put some steps there. One first step that's going to make your life so much easier is always, always, always look to see if there's a GCF first. Then, look to see if it's the difference of two squares. Then look to see if it's a perfect square trinomial. Those are kind of shortcuts. If it's there, take it. If it's not there, play the long game. From there, we're just going to factor it normally, and we're going to check our answer if we have to by FOIL. So let's just kind of take a look. I kind of created a couple problems here, and going from there. Let's look at example 4. First off, is there a GCF?
Yes.
What is it? 3. So let's put that out front. That doesn't mean we divide everything and lose the 3. We just put it out front. So x squared minus 25. I have 2 items, 2 terms inside my parentheses. Let's analyze them. They're separated by a minus. Are they both perfect squares? Yeah, so this is an example of we can go further with the difference of two squares. So we drag down the 3, and then we break it up into 2 parentheses. One's going to be a plus, one's going to be a minus, x and x, 5 and 5. And there it is. You can't lose the 3. You have to keep bringing the 3 along. Can't lose that 3. So that's just an example of a GCF first, and then the difference of 2 squares. All right, let's slide over here to example 5. Is there a GCF?
Yes.
Yes. What is it? 2. What's left when we take out the GCF? plus 6x plus, okay. I'm going to bring down the 2. I'm going to put my parentheses like so. What are the signs in my answer? Plus and plus, because we look right here and we see that the C is a positive. And then after that, we look over here and we see that the B is also a positive. So that leads us to positive, positive. What is absolutely for sure? X and X. What factors of 9 add to 6? 3 and 3. There we go. Now we're not quite done, but question for Zach.
So do we just ignore the 6x in that situation?
Well, we don't really, because if you were to FOIL this, Zach, you would see there's 3x there, and there's 3x there, which gives you the 6x. So we're not ignoring it. It's actually a big piece of the problem. Does that make sense? Now, our final answer on this one, we're going to write it. Sorry, Mr. Fritz. We're going to put a 2 out front, and we're going to say x plus 3, the quantity squared. And that should start to look familiar to vertex form of our warm-up stuff. And now you start to see the tie together as we look through these. All right, let's slide over to example 6. Or slide down to example 6. Not sure why we have 2 4s and 2 5s twice. Oh well. Talk to me. Thoughts? Where can we start?
Divide by 4.
Divide by 4. So let's take out that GCF, everybody. Nice job, Abby. Okay, somebody else. Next step. Richard, Jonah, Sebastian, Joey.
Then you can just do split it up into x plus 10.
Okay, x plus 10, x minus 10. Do we need to keep the 4? Most definitely. May I write this as x minus 10 squared?
No.
No. Okay, so I just got to keep it the way it is. This is the difference of 2 squares. Hopefully when you see these, they're pretty telltale signs of what you have. All right, come over here to this next one. Once again, is there a GCF?
Yeah.
What is it?
3.
All right, who can divide? I can divide the 27 by 3. What's 54 divided by 3? 18.
Right.
Mm-hmm. All right, bring down the 3. X and X. The back one is a positive. That means it's either 2 positives or 2 negatives. How do we know which it is? Look at the middle. 2 negatives. Good, Jonah. So the middle gives us our ticket there. 2 negatives. So now I'm going to go over here and write my factors of 18. 1 and 18, 2 and 9, 3 and 6. Which of those combine to get negative 9?
3 and 6.
3 and 6. And that's my answer. Had you not done the GCF, you'd be taking factors of 54 and all those kinds of things. So it's really important to do that GCF first. Remember, you cannot just drop this 3 either at the very front. You have to hold on to it. All right, let's slide down to number 6. What do you notice is different? So let's factor it out. We never want to have our x squared be negative. So let's take out a negative 1. X squared plus 5x minus 14. Richard or Joe, give me your thoughts there. Can either of you tell me my signs? Positive and negative. Richard, would you agree?
Yeah.
Because it's a negative 14. All right, would you agree it's x and x?
Yeah.
Okay. Factors of 14 over here to the side. 1 and 14, 2 and 7. Doesn't really matter. You can throw them in. 2 and 7. So that's negative 7x, positive 2x. It's a little messy there. Yeah, it looks like we have negative 5x and we want to have positive 5x. So remember, that's where we change the signs. So this one's going to be a negative, and that one's going to be a positive. So let's write this cleanly. The opposite of x minus 2 times x plus 7. I'm going to erase this extra stuff here at the bottom. The reason I just put an opposite in front and not a negative 1 is you will never see the book put a negative 1 in front of the parentheses. It'll just be a minus sign.
Okay.
It's not wrong putting a negative 1 there. As we say, it's just awkward. Questions there? All right, let's slide over. Talk to me. Thoughts? Stephen, Luke, Anna, Grace, what are your thoughts on this one? Start by doing what?
Review 4 and then parentheses x squared minus 8x minus 12.
So she took out a GCF. All right, drag down the 4. X, X, signs, minus, minus, plus, minus, plus, plus. Plus, minus. Factors of 12, 1 and 12, 2 and 6, 3 and 4. Which one of those, using a plus minus, gets you to negative 8? 3 and 4 gets you to 1 or negative 1. 2 and 6 gets you to? Does it?
It gives you to 4.
Well, if we have 2 and 6 there, that's going to get us to 4 or negative 4. 1 and 12 gets us to 11 or negative 11. So do any of these factors work? Okay.
Is it
So that's the answer. Is it possible that there's only a GCF and it doesn't go further? Yeah. And I wanted to show you that intentionally because you can't just be in this robot mode where, oh, it'll go here to here to here and it's got to work. We've got to actually think through these, Paul, and be like, okay, do they actually add or subtract to the middle term? And if they do, you go further. In this case, they didn't. And so, in this case, this actually is our answer. It's not going to happen that often, but it might. And I wanted to make sure you were aware of that fact. All right? Questions? So let's do a quick little review here. Reviewing foiling from the very beginning. The difference of two squares. Remember that a plus b and that a minus b are called conjugates. So we have that. Big picture, as Grace talked about. A quadratic is a parabola, and we're trying to find down the road, we're going to be finding where these things are equal to 0. And then understanding, look for a GCF first, and then start your factoring. Sometimes it'll be the difference of two squares, sometimes a perfect square trinomial, like this one was. Then sometimes it's going to factor, and sometimes it might, like example 7, just take out a GCF and go no further, even though it feels like it should go further. Okay? All right. I took in my textbook and I clipped in your stuff for you here to make things a little bit easier for you. You'll notice on 51 through 65, you've got a number of problems there that very likely are going to have a GCF in there. So you're going to want to kind of try to consider that first as you look to the problems. Okay? So we've got about 6-7 minutes. Hopefully you can do a couple while we're here.